Good day, ladies and gentlemen. We are the Group 3 and we are assigning to discuss about metallic mineral deposits. By the way, let me introduce first myself. So, I'm Randy Larez, together with Shirley Vertigaso, the leader, and our co-member, Aro Junel, Balili Christian, Kunal Sedi, Dehan J, Escalada Darlu, Squadron Francis Kiven, Ilaga Anafe, Husay Jessa, and Asayaw Generous. Moving on, our objectives at the end of the discussion, the learners will be able to first learn the origins and genesis of some metallic deposits. Second, learn the physical properties of these metallic deposits. Third, determine the location of these metallic deposits, occurrences in the Philippines, and discover how these metallic deposits can be used in variety of sectors. So to start, the first metallic deposit is chromite. So what is chromite? So as we know, chromite is an oxide mineral composed of chromium, iron, and oxygen. So its chemical formula is FeCr2O4. So it is dark gray to black in color with metallic to submetallic luster and the high specific gravity. So it occurs in basic and ultrabasic igneous rocks and in metamorphic and sedimentary rocks that are produced when chromite-bearing rocks are altered by heat or weathering. So chromite is important because it is the only economic ore of chromium, an essential element for a wide variety of metal, chemical, and manufactured products. So many other minerals contain chromium, but none of them are found in deposits that can be economically mined to produce chromium. Next is the properties of chromite. So chromite can be challenging to identify. Several properties must be considered to differentiate it from other metallic ores. So hand specimen identification of chromite requires a consideration of color, specific gravity, luster, and characteristic brown streak. The most important clue to identifying chromite is its association with ultrabasic igneous rocks and metamorphic rocks such as serpentinite. So chromite is sometimes slightly magnetic. This can cause it to be confused with magnetite. So chromite and ilmenite have very similar properties. Remember, careful observations of hardness, streak, and specific gravity are required to distinguish these minerals in hand specimens. Moving on, how does chromite form? So we have this called ternary phase diagram. So this diagram shows how main silicate minerals such as olivine, pyroxene along with chromite crystallize from high temperature melt. So as we all know, the melt was introduced into magma chamber as a liquid. 4 to 6 kilometers below on the Earth's surface minerals began to crystallize at point A. So in point A, it is where olivine minerals crystallize along with chromite. Next is as it cooled, so it reached point B. So the boundary where both olivine and chromite crystallize. And so if the melt is not changed in composition, it continues to cool, precipitating olivine and chromite along the line until it reaches point C. So at C, it begins to precipitate pyroxene and much less chromite. Take note, in the diagram, there's no massive chromite layers formed. So in diagram, also we can relate to Bowen's reaction series, where point A determines as the highest temperature where olivine first to crystallize, and point D is the lowest temperature where orthopyroxene crystallize. And so, as you observe in the diagram, as chromite crystallize along with other minerals, one point to another, but as it reaches other point, from silicate minerals, the chromite began or produced less chromite. So the reason is because of the characteristics of other silicate minerals. Next is types of chromite deposit. We have two. So the first is stratiform deposits. So stratiform deposits are large masses of igneous rock that cooled very slowly in subsurface magma chambers. So during the slow cooling, chromite and the associated minerals crystallized early while the magma was still at very high temperature. So their crystals then settled to the bottom of the magma chamber to form layered deposit. Some of the layers in this deposit can contain 50% or more chromite on the basis of weight. So most of the world's known chromite occurs in two stratiform deposits. So the Bushveld complex in South Africa and the Great Dyke in Zimbabwe. Other important stratiform deposits include the Saltwater complex in Montana, the Kemi complex of Finland, and the Orissa complex in India. The Guisas in Brazil, the Mashaba complex in Zimbabwe, and small deposit in Madagascar. Nearly all of these are Precambrian in age. So the second is the podiform deposits. So podiform deposits are large slabs of oceanic lithosphere that have been thrust up onto continental plate. So these slabs of rock, also known as opulites, and can contain significant amounts of chromite. In these deposits, the chromite is disseminated through the rock and not highly concentrated in easy-to-mine layers. Podiform deposits are known in Kazakhstan, Russia, Philippines, Zimbabwe, Cyprus, and Greece. So the first discoveries of podiform chromite deposit were made near Baltimore, Maryland in the early 1800s. So these deposits supplied nearly all of the world's chromite until 1850s. These deposits were small and no longer in production.
So now let's proceed to the grades and types of chromite ore. So in metallurgical, we have 45 to 56% of chromium oxide. On refractory, we have 30 to 44% of chromium oxide and 25 to 30% of aluminum oxide. On chemicals, we have less than or equal to 44% of chromium oxide. So next is the uses of chromite. So the chief uses of chromite are number one, to form alloys with nickel, iron, or cobalt. The addition of chromium imparts hardness, strength, and corrosion resistance to the alloy. So, ang chromium is one of the most popular alloying metals when it comes to steels. Kaya ang scale of hardness is high man as well as ang iyang corrosion resistance. And since kabalo naman kita that ang alloy is the combination of two or more metallic elements to give a greater strength or the resistance to corrosion. Like for example, ang chromium is like ginaad nato siya sa cobalt para ma-obtain nato ang iyang corrosion resistance as well as ang iyang hardness. Number 2. In stainless steels, chromium makes up to 10% or more of the final composition. Because of its hardness, an alloy of chromium, cobalt, and tungsten is used for high-speed metal cutting tools. So, the example of a metal cutting tools is like mga drilling machines, milling machines, and grinding machines, and others. So, the reason why there's an alloy of other elements like the cobalt and tungsten, it's because ang cobalt is nag-improve siya when it comes to heat resistance as well as it enables increased hardening temperatures. So ang tungsten is nag-increase po din ng iyang tempering and wear resistance. Kaya diba tempering is a metallurgical process wherein atuwa siya i-heat into a high temperature na moabot na sa iyang melting point. Then atuwa na siya ipakul usually through the presence of air. Ang wear resistance, it refers to a material's ability to resist material loss by some mechanical actions. When deposited electrolytically, chromium provides a hard, corrosion-resistant, lustrous finish. For this reason, it is widely used as a body trim on automobiles and other vehicles. Chromium plating represents to a large portion of the total Philippine chromium consumption. Like for example, sa cars, ginagamit ko lang chromium as body trims like sa mga roofs, bumpers, hoods, tailgate, o guban pa. So, ang kaning chromium plating is ginagamit ini siya as protections to be corroded. Technique ini siya that electroplates a thin layer of chromium into a metal object. Although may kamahalan ini siya pero worth it man sab kay para dili-dali magabok or makalayngon ang imuhang materials o ang imuhang vehicles. Number 4, chromium is a constituent of certain green, yellow, orange, and red pigments which are used as mordants to fix dyes. Ang mordants is amo ni siya ang mga elements or mga substance na ginaad like kanang mga iodine, aluminum, iron, mga copper o guban pa. Number 5, chromium when alloyed with tungstens, cobalt, and molybdenum produces stellite, which is used for high-speed machine tools because of its strength and heat resistance. The stellite is a non-magnetic alloy which contains a variety of different metal components with the main elements being cobalt and chromium. So, stellite is a group of cobalt-chromium superalloys that is characterized by great hardness and resistance to corrosion and high temperatures na ginagamit paghimo sa mga jet engine parts and kanang mga cutting blades. Number 6, chromium refractory bricks are used for lining furnaces. The refractory brick is a block of ceramic material that is used in linings, furnaces, fireplaces, and fireboxes. So, natay different types of refractory bricks. Ang isa na diri ang chrome refractory bricks. So, ang chrome refractory bricks is made up of 50% of chrome iron ore. So, under ini siya sa neutral refractory bricks. Number 7, so a number of chromium compounds obtained by the chemical treatment of chromite have great importance uses in industry. So, sodium dichromate, metal treatment processing, glass etching, bright dipping of brass to control the rates of solution of oxygen and zinc in brass, and acid cleaning of aluminum and magnesium. So, one of its application is that the sodium dichromate is used to prevent the corrosion of a metallic surfaces as well as the color of the glass production. Next is the acid cupric chromate. So, timber preservative for preventing the corrosion in air conditioning plants. Potassium and sodium dichromates. So, these are used as corrosion inhibitor in fuel tanks of naval aircraft and boilers. So, cooling towers and automobile engines. So, next is the chrome green. So, these are used in protective paints because of its great stability and permanence. Then, lead chromate, it gives lemon to orange color. And then, zinc chromate, it gives a yellow pigment. So, we will proceed now to the chromite occurrence in the Philippines. So, mostly makita natin ang mga chromite deposits in Masinloc and Santa Cruz, Zambales. Then, Llorente, Eastern Samar. Then, Puerto Princesa and Nara, Palawan. Then, next is in Paluan, Sablayan, and Lubang Island that is located in Occidental Mindoro. Then, Loreto, Dinagat, Humunhon Island that is located on Eastern Samar. Then, San Mariano, Palawan, Isabela, and Impasugong, Bukidnon. Then, another fact is that the Zambales ophiolite is a major source of chromite ores here in the Philippines.
Manganese. What kind of metal is manganese? Manganese is a silver gray, chemically active element with Mn as symbol. It is a hard and very brittle metal that reacts with water and dissolves in dilute acids. The metal tends to rust like iron when exposed to water. How was manganese discovered? Proposed to be element by Carl Wilhelm Scheele in 1774. Manganese was discovered by Johann Gottlieb Gahn, a Swedish chemist, by heating the mineral pyrolusite in the presence of charcoal later that year. The derivation of the name manganese came from one of two routes, either from the Latin magnes, meaning magnet, or from the black magnesium oxide, magnesia nigra. Where can you find manganese in nature? Manganese does not occur in the pre-state, except meteors, but is widely distributed throughout much of the Earth's crust in combination with other chemical elements such brunite, rhodonite, and manganite. Manganese nodules on ocean floor holds contain about 24% of manganese and usually located at the depths of 4,000 meters. Physical properties of manganese: color, silver gray, streak, dark gray, luster, metallic, transparency, opaque, cleavage, none, hardness, 6.5 on Mohs scale, specific gravity, 4.0 to 5.1, chemical composition, Mn, density, 7.01 gram per centimeter cube, crystal system, isometric.
Good day everyone, I am CD Kunol and I've been given a task to discuss about the formation of manganese ore. We all know that sedimentary deposits are the most abundant types and they are formed by the deposition of material at the Earth's surface and within the bodies of water. And manganese ore is a sedimentary deposit. Og na-form kini na ore deposit through concentration in seawater, precipitation from seawater, and enrichment in the sediments. And there are three mineralizing process to be considered in the formation of manganese ore. Una, ang hydrothermal. Kung moingon tag hydrothermal, it simply means hot water. And it is referring to those mineral deposits that are formed in precipitating from hot fluids that circulate through the crust. Ang ikaduha na mineralizing process para ma-form ang manganese ore is sedimentary processes. Kung maingon tag sedimentary processes, nagpasabot na kani ang manganese ore is a result in the concentration of ore forming minerals from the lake or sea water. And lastly is surficial processes. Kung maingon tag surficial processes, pasabot na kini na ore is accumulated through processes that take place on the earth's surface, such as erosion.
So, here is the classification of manganese deposits. Gilbert and Park of 1986 stated in their book on the geology of ore deposits that Roy of 1976 classified stratiform manganese deposits into two broad groups, non-volcanic and volcanic sedimentary, according to the source of their contained manganese as follows. The volcanogenic and non-volcanogenic. In volcanogenic, we do have two associates. The first one is that deposits are associated with agglomerates, tops, and other clastic materials of subaerial or submarine hot spring affinity. Meaning, there are manganese that is formed with other clastic materials within the affinity of subaerial or that it is formed on or near the Earth's land surface. The second one in volcanogenic is that deposits are associated with banded iron formation of distal submarine exhalite origin, meaning that the manganese can also be formed with banded iron form of distal submarine exhalite, that it can also be formed in the sites located away from a specific area. So, we come now to the non-volcanogenic. When we say non-volcanogenic, this is not associated with any volcanic activity. The bog ore, lacustrine, and fluvial settings, the continental terrigenous sediments in geosynclinal or shelf settings. When we say shelf settings, it is a portion of continent that is submerged under an area of relatively shallow water known as shelf area. Much of these shelves were exposed by drops in sea level during the glacial periods. So, we do have also the Philippine manganese deposits that are classified as primary or secondary. The former are the volcanic sedimentary deposits, while the later are the residual deposits that have resulted from the withering of manganese-bearing rocks. So, here are the uses of manganese. Manganese is used to produce a variety of important alloys and to deoxidize steel and desulfurize. It is also used in dry cell batteries. Manganese is used as black-brown pigment in paint.
Good day everyone. So let's proceed to the copper. So as what you can see in the picture, we can point out two obvious physical properties. So first, it has a brownish red metallic element. Ibig sabihin, its color is brownish red. And then second, it doesn't have cleavage but it has fractures. Fractures lang siya kasi ang pagkabiyak-biyak ng bato is hindi pantay or uneven. So yun. Copper is one of the most widely used metals in this world. This metal was known to prehistoric people pa and was probably the first metal to be discovered. Kasi nga, according to my research, 4,000 to 3,000 BC pa siya na-discovered. So if we imagine that, it is from ancient Egyptian pa to Romans up until today. So yun. It is a major industrial metal because first, it has a high ductility. Ibig sabihin, it can sustain a large permanent deformation. Second, high malleability. It is capable of being shaped when it is hammered. Then third, high thermal and electrical conductivity. Ibig sabihin, when the copper is extracted from the ore and became a product like electrical wirings, the electric current can easily pass through. Then lastly, resistance to corrosion. Ibig sabihin, it can prevent environmental deterioration. So, hindi siya basta-basta nangangalawa. So, here are the physical properties of the copper. So first, its chemical classification. So si copper is a native element. Ibig sabihin, it exists in the Earth's crust as a single and pure element. Second, its color, nasabi ko na kanina, it's brownish red metallic elements. And its streak or its powdered form is metallic red pa rin. Then its luster, so when this rock is exposed to light, and makikita natin yung surface niya is more like shiny siya. So, it's classified as metallic. So, for transparency, it's opaque. Ibig sabihin, it can't be see-through or hindi siya transparent. Then, cleavage is none. But I highlighted kanina na it has fractures. Ibig sabihin, fractures na uneven. Yun. Then, its hardness ranges from 2.5 to 3. Then its specific gravity is 8.9. For diagnostic properties, nasabi ko na kanina yung mga luster, color, specific gravity, transparency, yun, etc. na. Then chemical compound or its symbol is Cu. And its crystal system is isometric. Ibig sabihin in a cubic shape or cube shape. Yeah. And as for the origin of the copper, so copper is found in the oxidized zones of copper deposit, in hydrothermal veins, in the cavities of the basalt that have been in contact with hydrothermal solution, and as a pore fillings and replacement to conglomerates that have been in contact to hydrothermal solution. So cavities are the empty spaces or voids present in the basalt rock. So copper is present in the Earth's crust at a concentration about 50 parts per million. So where it occurs as a native copper or in minerals such as copper sulfides, chalcopyrite and chalcocite, or copper carbonate, azurite and malachite, and copper oxide mineral like cooperite. So let's proceed on how copper is formed. So copper is formed naturally. It is a metal that has been deposited from hot sulfur solution created in the volcanic region. So the hot solution concentrated the copper up to 1,000 times more than would normally be found in rocks. So the resultant enriched rocks are called copper ores. So to understand how copper is formed, it is helpful to look and understand what is porphyry deposit. So porphyry deposits are the largest current source of the copper ore. So the ore bodies are formed in hydrothermal veins that are born in underground magma chamber that far below the deposit itself. So the high temperature of volcanic magma creates a hydrothermal veins that allows heat to escape in the near upper Earth's crust. This is why copper is often found in the sedimentary layer, where sand and mud are compressed until they form sedimentary rock. So the copper ores are trapped in oxidized zones within these types of rocks. So nasabi ko na kanina that copper ores are usually found in oxidized zones and in basalt cavities that has been contact with hydrothermal solution. So the presence of volcanic regions are the good indicators na in that area maraming copper ores. Why? Because the basalt cavities are usually located in that area.
Now let's move on to the different sources of copper. The sources of copper are considered into two categories, primary sources and secondary copper minerals. Kung maingon tag primary sources, mao ni sila ang mga ginatawag na sulfide ore o ginaprocess ni sila ng mga ore through flotation to obtain copper concentrate. The two common sulfide ore are chalcopyrite and bornite. And chalcopyrite, which accounts for about 50% of copper production, and copper ores containing chalcopyrite can produce a concentrate with 20 to 30% copper in concentrate. Secondary copper minerals, on the other hand, mauni sila ang mga oxide ore of copper. Kini na mga copper ore, ang ila primary copper ore minerals are oxide. The following are the different uses of copper. Ang copper good is very useful not in our society but also in our day-to-day living. It is mostly used as wiring kay tungod it is an excellent conductor of electricity. Aside from that, it is also an excellent conductor of heat, and that is why kadalasan natong makita na cooking utensils are made up of copper. It is also used to make alloys such as brass and bronze, and copper is also alloyed with the precious metals.
Hi everyone, so I will be the one who will discuss to you about the copper deposits in the Philippines. According to the history, Philippines is the fourth largest country in the world in terms of copper reserves, estimated to be 4 billion MT. So the Tampakan deposit is a large copper and gold ore body with an estimated resource of 2 billion tons of ore grading 0.6% copper, located in the south of the Philippines in Tampakan, South Cotabato. Classification of Philippine copper deposits. So the most important copper deposits in the Philippines are of the porphyry type. They range in age from Cretaceous to Pleistocene, although most are within the Middle Miocene-Pliocene age range. Other deposits are classified as volcanogenic massive sulfide or VMS, epithermal vein type, and less importantly, skarn type. So there are four classification of copper deposits in the Philippines. The first one is porphyry copper, in which these deposits are hypogeum sulfide deposits, in which the ore minerals are decimated in the form of grain impregnations and or network of vinlets within acid to intermediate bodies and the rocks they intrude. In the Philippines, this type of deposit is of utmost importance. So this type of copper deposits is one of the reasons why the Philippines becomes the fourth largest country that produces copper reserves. The second type of VMS is cypress type, which refers to the massive sulfide base metal sulfide ores associated with rocks of mafic ultramafic association of aphyolitic affinity. The ore bodies are lens-shaped pyrite chalcopyrite ores contains in spilitized basaltic pillow lavas, which are apparently the product of relatively deep water, quiescent, fissure eruptions in the seafloor. In the Philippines, this type of deposit is exemplified by the Barlo, Bongbongan, Malabog, and the Port Bicobian mines. These copper deposits are found at the top of aphyolitic sequences, the host rocks consisting mainly of Cretaceous Paleogene sphalectic basalt flows and the pilolabas, tufaceous interveds, and cherty sediments. The Coroco-type copper deposits in the Philippines are associated with andesitic to rhyodacite flows and pyroclastics and intercalated normal sediments. In general, these rock associations are imposed over Cretaceous Paleogene basement complex coincident with the distribution of the apoleutic terrains. Most of the deposits occur in Neogene volcanic sedimentary sequences, such as those of Bagakay and Sulat in Samar Island. However, some are in association with older formations, such as the deposits in Dopax, Nueva Vizcaya, and in San Mariano, Isabela. The third type is the Beshi type, which is the last one. So the description for the Beshi or Kislager type copper deposits is that of stratabon massive cupriferous iron sulfide deposits, bed-like or lenticular in form, that lie conformably in crystalline cyst. It is now recognized, however, that this type of deposits are simply metamorphosed VMS deposits of either the Coroco or Cyprus types. Of several occurrences of this deposit type have been identified in the Philippines, but only the Hexbar mine most developed in the production. The deposits occur mostly in pre-Cretaceous basic and peletic crystalline quartzose schist.
Gold is a chemical element with symbol Au and atomic number 79. In its purest form, it is a bright, slightly reddish yellow, dense, soft, malleable, and ductile metal. And gold is one of the least reactive chemical elements and is solid under standard conditions. The table shows the physical properties of gold. In mineral classification, gold is considered as native because gold can resist natural withering processes like oxidation. The color of gold is rich yellow, peeling to whitish yellow with increasing silver, blue and green in transmitted to light. The color of gold in its powdered form or the streak of the gold is shining yellow. It has a metallic luster and its fracture is jagged. The hardness of gold is 2.5 to 3. Its chemical composition is Au. It is also a member of copper group and its crystal system is isometric or having an equal dimension. Usually, ang gold occurs in free elemental form such as nuggets or grains in rocks, in veins and in alluvial deposits. The occurrence of gold is usually associated with copper and lead deposits. Maski man gamay ang quantity ng gold na makuha sa ana na deposit, but gold is still the readily recovered as byproduct sa pag-refine of those base metals. Gold is also occurred in solid solution series together with the native element of silver ug usahay sab it is a naturally alloyed with copper and palladium. And less commonly, it occurs in minerals as gold compounds, often with tellurium.
So let's move on to the two types of deposits where gold can be found. First type is the hydrothermal veins. The term hydrothermal, when used in the context of mineral deposits, means that the minerals have been formed from a hot aqueous fluid of unspecified origin. Many styles of ore deposits are considered to have been deposited from hydrothermal fluids, and that are most commonly filled with quartz and calcite, the gem varieties of low temperature, silica, and in some emerald or topaz, and it also associated with quartz and pyrite or the false gold. The second type is the placer deposit. Placer deposits are masses of unconsolidated and semi-consolidated clastic sediment formed by surface weathering and erosion of primary rocks that are subsequently transported by gravity, water, wind, or ice from their original source and are deposited elsewhere. Next is the uses of gold. As a natural element, gold has many special qualities that make an important raw material in a number of scientific applications. For example, gold in dentistry. Gold is distinctly useful to dentistry for two reasons. First, it is very malleable and easy to work with. Second, it is completely insert saliva and one-body chemistry. Next is gold in electronics. Gold is a top-notch electrical conductor, so it's used to build capacitors and establish electrical connections. Gold is an important component in nearly every electrical device, unlike copper and silver, which are also prized for their electrical conductivity. Gold never corrodes. Electronic devices that use gold tend to last much longer. Besides its value to the jewelry, finance, and refining industries, gold is also priced in. And also, gold has the high economic value. For the last is the gold occurrences in the Philippines. Deposits of gold are clustered with four districts, that is Baguio, Mankayan, Camarines Norte, and Masbate, and one gold province is the Eastern Mindanao. Several sporadically distributed areas of gold mineralization are also recognized.
Silver is a precious metal which belongs to the group 11 in the periodic table, has an atomic number of 47 and a symbol Ag. It has a metallic luster. It is soft as it has a hardness of 2.5. It is very ductile as it can be stretched and malleable as it can be hammered into thin sheets. Silver is not a chemically active metal, so it does not oxidize in air. However, nitric acid and hot concentrated sulfuric acid will react with it, which will cause the metal to tarnish due to the formation of silver sulfide. Hence, silver products require regular cleaning. Archaeological evidence suggests that people have been using silver for at least 5,000 years. So unlike gold, silver is present in many naturally occurring minerals. It can be found in the Earth's crust in the pure, free elemental form as native silver, as an alloy with gold and other metals, and in minerals such as argentite and chlorgerite. But most silver is produced as a byproduct of copper, gold, lead, and zinc refining. So, diri sa Pilipinas, kung asa tong occurrences ng copper, gold, lead, and zinc deposits, naasay silver na ma-produce as a byproduct kung i-refine na to ng mga metals. Silver can be used in various areas such as in photography, in which photographic film strips contain silver, in dentistry as kanang pasta bitaw, as cutlery like spoons and fork, and also in mirrors as a catalyst in oxidation reactions, because silver can increase the rate of a chemical reaction such as in the formation of formaldehyde. It can also be used in batteries, to make coins and jewelry, and since silver has the highest electrical conductivity of all metals, it is used in electrical and electronic industries such as in circuit boards. However, it is not widely used as it is very expensive.